Okay, so let's see what we get when we put Helena's information into the solver. So we need to go back up to the thing we don't know, which is the present value, and do alpha, enter. All right, and so then it tells us that the present value, remember it's going to give it as a negative number, but we're going to report it as a positive number. So $4,282, and that 9 cents rounds up to 10 cents. Let's look at the next one. So I did solve the next one, but I'm going to go through it with you. So how long must Magnus invest $4,000 at 6.45% PA compounded half yearly, so that's 2 times per year, for it to amount to $10,000? So we don't know how many years, but since it's twice a year, N will be 2 times the number of years. The percentage rate is it's 6.45, and the initial investment is $4,000, which we report as a negative number. We're not making any payments, and we want to know when it's going to be $10,000. And since it's compounded half yearly, we'll put 2 here and here. So you can see that in the calculator here, and we found the value here. We cannot see this in the calculator yet. We're going to put that in the calculator right now. So let's put those numbers in. Okay, so I've updated the calculator. I need to go back to the thing I'm trying to find out, which is N, and do alpha, enter. So we get this number here, 28.86, etc. And that means that 2 times the number of years is equal to this. I'm going to divide it by 2, and rounding to 3 sig figs, I get 14.4 years. Okay. Down here. In this one, Iman is depositing $5,000 into an account that compounds the interest monthly. And 2.5 years later, the account has a balance of $6,000, and we're trying to find the rate of interest. So I have an answer here, but I'm going to show you how I got that. N was monthly, so 12 times, and 2.5 years, so that's 30 times it compounded. I started with $5,000 and I ended with $6,000, and still no payments, and since it's compounded monthly, I have 12 here and here. So if you were to use the calculator on that, then you would get an interest rate, and this one, because it's not money, you can round this to 3 sig figs, and we get 7.32%. So let's turn the page and talk about amortization. Oops. Okay. So this is the process of repaying a loan over a fixed period of time. Most commonly, the questions will be about mortgages or loans taken out for a large purchase like a car. Interest is paid on the original amount, and as the amount grows bigger, interest is paid on that bigger amount. Each repayment that is made will partly repay the original loan and partly repay the interest on the loan. So here's what happens. Olivia takes a mortgage of 280,000 euros to purchase a house with an interest rate of 3.2% compounded monthly, so 12 times a year. She agrees to pay the bank payments of $1,500 at the end of every month, and we need to find the number of years and months it will take Olivia to pay back the loan. So we're going to start over here. We don't know how many years, but we know it's compounded 12 times. So it'd be 12 times the number of years. The interest rate is 3.2. And the present value is $280,000. And that money is coming from the bank to Olivia, so it's positive. The payments, however, go from Olivia to the bank, so those are negative. So we're going to put that and this information into the solver. And what we're going to get is we're going to get a value for 12x. So when you put that into the solver, you should get that 12x equals this number, and we divide it by 12, and we get the number of years. But we want to know the number of years and months rounded to the nearest month. So we're going to take this value and multiply it times 12 months per year. 6.61 months will round to 7 months, and so it's going to be 21 years and 7 months. All right, let's look at annuities. So an annuity is a fixed sum of money paid to someone at specific intervals over a fixed period of time. Most commonly, this is because of an initial lump sum investment which will be returned at fixed intervals of time with a fixed interest rate, either from personal savings or from receiving an inheritance. So here's Janny. Janny invests 2 million Danish, I think that's pronounced Danish krone, into an annuity for her retirement. The annuity returns 3% compounded annually, and we're trying to find the monthly payments Janny will receive if she wants this annuity to last for 25 years. All right, so in this case, 25 years times 12 times a month, it's going to be compounded 300 times. The future value after 25 years is 0 because we're going to use up the whole entire amount. The interest rate is 3%, and there will be 12 payments per year. The present value is the money that Janny gave the bank, so that's negative. And the payments are what we're trying to find. And in this case, we're going to have payments at the beginning. Now she's going to get 12 payments per year, but the interest is compounded annually, so that's just once a year. So we're going to put this into the calculator and see what we get. Okay, so notice that this time I'm changing the payment to beginning. And then I'm going to go back to the thing I'm trying to find, which is what will the payments be? And I'm going to do alpha, enter, and it looks like the payments are $9,418.95 per month. So let's put that down. This is going to be in, nope, not dollars, but Danish krone. $9,418 and 90.95. Although I believe that the Danish krone are not rounded to the hundredths place. I believe they're rounded to the whole, or maybe the half, but not to 0.95. So we're going to round that to DKK 9419.